Hey everybody, so I'm Mr. Phelps, and welcome to this IB math writing course. I mentioned before, I'm really excited about what it is that we're going to be trying to do this summer and through these videos. I've got some ideas about what I want to do, but it's still kind of forming, and so I'm really excited that you guys are here with me as we begin this thing. So in this first video, in this first lesson, I want to provide basically an introduction to mathematical writing. And to do that, I really want to essentially start at the beginning. Okay? And so when I say start at the beginning, I mean I need to tackle a question like, what is math? Like if we're going to talk about math writing, I do think that we need to go sort of beyond just our basic sense of what math is and what a math class is. And so what I want to sort of start off with is by asking you, what do you think? Like, I want you to pause the video for a minute and think, how would you define mathematics? Based on your past experience, based on your education so far, I want you to sort of think about, like, what is math? And I don't, this isn't a right or wrong kind of thing. I'll give you my definitions in just a minute, but I want you to think about that. All right, so hopefully you thought about that, you gave it a little bit of time. And by a little time, I mean like a couple minutes. So here we go. My definitions. Oh man, the video cut off that S. Oh well, we'll deal with it. So my definitions. So first, I think I'd say that mathematics, or maybe what we would call pure mathematics, is the study of patterns, properties, and relationships that occur among or between mathematical objects. This is math that's done for math's sake. So when I think about math, I really think about what patterns do I see? How do I prove those things? What properties do these numbers or these things have? What relationships do I see between, this type of mathematical object and this type of mathematical object, or this thing that I did in this type of mathematics and this sort of thing that I'm trying to do over here? But when I do those things, I'm doing them without any regard or any thought to how I'm going to use those things. I'm just doing math, not going to lie, for fun. Okay? Now, there's another side to mathematics. It's called applied mathematics. Okay? And so to me, I feel like I understand that applied mathematics is sort of the study of the application of those mathematical principles to real world phenomena. And that could be through science, that could be through statistics, that could be through like looking at a relationship between like what's happening to something and a relationship you see in a function. But applied math is really math that's done with the purpose of arriving at some sort of a usable result. Okay? Now, I want to be very clear here because when I was your age, contrary to what 18-year-old Phelps would have said, neither one of these is better than the other. In my youth, I would have said, oh my God, pure mathematics is like the real mathematics and applied math is just this like kind of whatever thing. And that's messed up. That's elitist. And I have recognized where I came from. I still very much prefer pure mathematics. I like to do pure mathematics. I don't really enjoy applying math all that much. But I'm not going to say that it's a lesser mathematics. It's just not what I enjoy as much, and that's fine. You might enjoy applied mathematics much more than pure mathematics, and that's okay. These are both math. They're all math. Okay? Now, the next thing I want to talk about is sort of this idea of there's a difference between doing math and communicating math. And so I think the first question that I want to ask and that I want to encourage you to reflect on is, can I do one of these without the other? What happens when I try to do one or the other of them? What happens when I try to do just one of them and try not to do the other one? And that's going to lead into this question of why do we need to write in a math class? And so I want to encourage you to sort of think through those think through those two questions. And kind of like we did before, I want you to see what you can do to come up with answers for yourself in terms of, is it possible for us to do math without communicating math? Is it possible for us to communicate math without really doing math? So take a minute to think about that. I'm of the opinion that, yeah, we can do math without communicating it. I do that all the time. I think about math in my head. I'm like trying to do things, or maybe I'm working something out on paper, but I'm not really trying to communicate it to somebody else. I'm trying to solve the problem for myself. And then, I don't have to communicate it. There's also times where I'm communicating with someone and I want to use math or I want to use some reasoning, but I'm not really using precise math. And so I want us to understand that doing math, either doing it in your head or doing it on paper just for you, and communicating math are not exactly the same thing. They're different skills. And a lot of the math that you have done and studied so far has really been doing math, not communicating math. And so when I ask this question, like, why do we need to write in a math class? It's because, if you can solve math problems, great. But if you can't communicate them to other people, that's problematic. Like we need to be able to do that, at least to some extent. And so this summer course, this thing that we're putting together, is really us digging into how is it different? What do we need to do? And so the next thing I want to do is I want us to sort of take a look at what are the things that we do when we actually do math, and what are the things that we do when we're communicating math, because we now know they're not the same thing. And so I want to sort of look at that. By the way, these next two chunks that I have about doing mathematics and about communicating mathematics, they were partially informed by the Math Extended Essay Guide that was published by IB. So I do this for two reasons. One of them is to say the following 4 points are not something I came up with. This is not me saying this. This is sort of the IB organization coming out and saying, hey, this is what we think is involved in doing mathematics. Now, some of you are like, whoa, I'm not doing a math extended essay. I get that. But if we're talking about writing math, we might as well have a target, have something in mind that we're working toward and looking at, okay? So one of the things that we do when we do mathematics is we use appropriate techniques to solve clearly stated problems. Okay? And honestly, this is something that you guys have already done a lot of, right? You learn some kind of technique, and then your homework is to do 12 or 10 or 15 or 5 problems with that, and you apply the technique to the problem. You apply the technique to the problem. You apply the technique to the problem. You notice there's not necessarily a lot of mathematical communication there. Some of you may be like, oh, I already know how to do this problem. I can do this one in my head. Do I need to show my work? And maybe I would say when you're doing mathematics, it's maybe not necessary that you communicate it perfectly clearly, but when your goal is to communicate, we need to do that more. So doing mathematics, one of the ways we do that is by using techniques to solve problems. Another one is, and this is doing mathematics, this is not necessarily communicating mathematics, making arguments using correct reasoning. Now, you might be thinking to yourself, wait a minute, like, how can I make an argument without communicating? Well, a mathematical argument is basically sort of step-by-step use of reasoning to show something or to demonstrate something is true. I could totally be doing that in my head. I could totally be writing that down on paper, not trying to communicate it to somebody else, just trying to make sure that I had my mathematical ideas kind of straight in my own head. This is doing mathematics. It's going to be related to communicating mathematics, but at its core, making an argument saying, when I add together two odd integers, I'm going to get an even integer. That's an argument, and you would need to use reasoning to show that it's correct. You need to sort of develop a proof for that. A third way that we do mathematics is by analyzing data using appropriate techniques. So maybe you've done a survey. Maybe you've gathered a bunch of data from some online repository of data. Maybe you've carried out some experiment and you've gathered a bunch of data. Analyzing that data using appropriate mathematical techniques is doing math. And so one of the things I'm trying to get at here is math is not necessarily just here's problem 1, here's the question, here's the answer. Here's problem 2, here's the question, here's the answer. Here's problem 3, here's the question, here's the answer. There's more to doing math than that. And the fourth and final one of these things is something called modeling. So modeling situations using correct methods is another form of mathematics. Modeling a situation is where you would say, I want to look at the way that something is happening, so I want to develop, I want to come up with variables, I want to develop formulas that will model what this thing is and how it's working and how it's doing. So modeling can also be a form of mathematics. Some of these things lend themselves more to pure mathematics, some of them lend themselves more to applied mathematics, but it's not like some of them are one and some of them they are the other. There's really a use for all of these things in both of those areas. So the next thing I want to talk about is communicating mathematics. So the last section we talked about was when you're doing mathematics, you're not necessarily communicating, you're just doing it. Those are what we do when we're doing mathematics. Now, when you're communicating mathematics, if I'm now trying to communicate that to someone else, either via communication, like talking, or via a written paper, or even via like a presentation that you're doing, anytime you're trying to communicate mathematics out to other people, whether it's one person or a group of people, these are the kinds of things that we're going to do. So the same thing, all of these ideas were taken from the Math Extended Essay Guide. I feel like that's a really great sort of starting point for helping students to understand what's involved in math writing. So the first thing we need to be able to do is or an example of communicating mathematics rather, is to be able to describe your way of thinking clearly. And this is really important, particularly for any of you who are like, oh, I can do it in my head. Okay, can you describe that clearly to other people? I sometimes hear people say, and it's not even about math, it can be about other things. They're like, oh, I have this idea in my head, but I can't find the words for it. Or you'll notice that you get like halfway through sharing something with a friend and you're like, I'm not explaining it right. When you're writing math, you don't want to have that feeling in the middle of it. And one of the ways that we avoid that is by planning ahead, by thinking about how we're thinking and figuring out how to put that onto paper and how to communicate that well to people. And so sometimes that's going to be by using English words. Like our math papers are not just going to be us writing out equations and formulas, and here's my answer, I put a box around it. We're going to want to be able to describe the way that we're thinking so that other people can see into our thought process. Another thing that we do is by using consistent and appropriate symbols, theorems, graphs, and diagrams. We're going to communicate with math symbols, we're going to communicate with equations, we're going to communicate with words, but we're also going to use things like theorems, the definitions. We're going to use graphs that are labeled and that we can actually read and see things on. We're going to use diagrams, sometimes color, to communicate the things that we're doing. But we want those things to be consistent and we want them to be appropriate, which means you want to use the same kinds of terms throughout a paper. You want to use the same kinds of symbols. If you don't have a symbol for something, you can literally make up the symbol. You just have to describe what it means and how to use it. The next thing that we do when we communicate mathematics is that we write precise definitions and conjectures. I don't necessarily know, and rather I should say this more strongly, I don't know what your mathematical background is. I don't know who you've learned math from in all of your previous years. I don't know what your experience with math is. But I know that for me, I'm all the time telling students, that's not quite how we'd use that word, or that's not quite how we'd use that variable. And that doesn't mean you're doing it bad. It just means that we need to correct those things. We need to be precise about them. I think math often prides itself on being very, very precise, very specific about what we're saying. And so one of the ways that you'll communicate mathematics is that you'll need to precisely define things. Say, this is what this is going to mean, this is how I'm going to use it. Okay? And then the last one of these things that I have is in justifying your conclusions. When I come up here and just say, I noticed something, anytime I add together an odd number plus another odd number, I get an even number. Okay, I can say that. I can make that conjecture. A conjecture, by the way, if you didn't know that word from before, conjecture is when I state something that requires some proof. You might be like, oh, that's really, that's a good point. When I take 7 plus 11, I get 18, that's even. You might notice, hey, it always seems to work, but how would I justify that? How would I explain to someone and convince them that that's always going to work? You would need to describe your thinking clearly. You'd want to consistently use things. You'd need to precisely state what your conjecture is, and then you need to justify that conclusion that you came to. So I hope that through these last two slides, you have gotten the idea that there's a difference between doing math and communicating math. And just like I said there was a difference between applied math and pure math, I'm not about to say that one of them is more important than the other or better than the other. They both play a really important role in our learning and understanding of math. So please, please hear me clearly on that. When we're writing math, or even when we're doing IB level math, we need to understand that there's a place for both doing math and communicating math. We need to be able to do both of them. And so now, I said I was going to start at the beginning, and so here we are. We're nearing the end of this first lesson. And so I want to have a sense of, so where do we start in this journey? Where do we start in this process of learning how to better communicate math and how to better write math? So I think it's really important that we start with you having a positive connection to some kind of mathematics. And so I want to ask you, I have a couple of questions here. I don't remember how many it is. I think it's 3 questions, or 3 bullets here. I want to encourage you to think about each of these things, and at the end of the video, I want you to pause, or rather, I want you to write down answers to these questions. I don't want this to just be something that's in your head. I want you to communicate onto your paper, which you will turn in to me and I will read. I want you to communicate to me the answers to some of these questions. And please, please, this is so important. Please don't try and impress me. Please don't try and give me the answers that you think I want to read. I really, really, really need to know, and more than that, I need you to know where you're coming from. Okay? So first I want you to think, what memories do you have of solving math problems? Like, when you stop and think for a minute, do you have any memories, like defined memories, of solving math problems? I have a bunch of them, but just to give you examples, these don't need to be like, oh, well, I remember when I was pondering a question that I saw about quantum physics. Like, you don't need to make something up for me. You don't need to impress me here. It might be as simple as, like, for me, I literally remember being at Valley Vista Elementary School. I remember being in Mr. Sanford's math class, and I was in 6th grade, and I think he called us the 76ers because we were doing like 7th grade math in 6th grade because I was like good at math or something. And I remember being like antisocial at the time, and I remember I would just like sit in a little room on the side and just do repeated math problems. Like, they weren't assigned. I just, like, during lunch, I just wanted to sit in there and do math. And so it's kind of sad, kind of like lonely or whatever. But okay, cool. Like, that's a memory I have of solving math problems. I don't know that I'm going to write a math paper about that, but that gives me some sense of who I am and the kinds of things I like to do. I like to sit and look at problems and look for patterns. Another memory I have of solving a math problem. Oh, this actually, hold on just a second. Actually, I'm wondering if this is the yellow notepad. I've taken like multiple. I studied math in college when I went to Berkeley, but since graduating, I've then gone back multiple times and like taken random side math classes, because I want to sort of experience challenging math again. I don't think I had. It's not this yellow pad. Bummer. I was hoping it was this one. I remember having a yellow pad of paper just like this one. And I was studying these things called they're called infinite. Sorry, this idea just occurred to me right now. They're called infinite continued fractions, or continued. What was I doing? I think I was doing radicals, where you do things like. Hold on, I'm writing this down on a thing so I can. Stuff like this, where you do like the square root of 1 plus the square root of 1 plus the square root of 1 plus the square root of 1 plus, and it's like, what the heck even is that? And what if I made them all 2s? What if I made them all 3s? What if I made it 1 2 1 2 1 2 1 2 1 2? What if I made it 1 2 2 2 2 2 2 2 2 2? Like, I was really interested in this question of like, how do these things work? And I remember being in this class at UCSD with Professor Evans, and looking at these things and finding these patterns, and it was so exciting to me. And I saw this relationship, and I showed it to my professor, and I was like, how can I show this thing? And he gave me some tips, and we worked through it. And it's not like I proved some new theorem. There's no Phelps's theorem, and if there is, it's not named after me. And I'm sorry I'm taking a lot of time on this, but I want to sort of share with you guys any memories you have of doing math, like share a couple of them with me. I should have done that one with this one. Do any math problems or questions stand out to you in your mind? So are there any problems that you have ever solved or had to solve that stand out in your mind, either as really positive or really negative? If so, share that with me. And it's okay if you don't remember what the exact numbers are. Just like get down onto paper, communicate with me about, and you don't need to tell me what the problem, you don't need to tell me how you solved it. I just want to know things that kind of stuck out to you. A third one of these, are there any numerical or mathematical related problems that you've always wanted to solve but haven't been able to or haven't taken the time to do? I'm going to share a random one here with you right now, and I'm probably actually going to study this one with you guys over the course of this class. I have a son. At the time of the recording of this video, he's 11, and he's super into Pokemon. He really likes playing all the Pokemon games, and particularly during like the pandemic time, he got really into like shiny hunting, and so he's like learning about like the Masuda method, if you know what that is. I mean, I kind of know what it is. And so sometimes he'll come to me with questions like, and I try to show him some basic probability and to figure these things out, but he'll be like, Daddy, I caught 30 Pokemon. What's the probability that one of those would have been shiny? What if I catch 100 more? And so I've shown him the formula, and we can figure it out pretty quickly. It's really not a hard problem to do. And if you don't know how, that's okay. I'm not judging you. I could show you too. But I always kind of wondered, like, I wonder if there's a way for me to come up with a way to mentally answer that problem. So that when he comes and says, oh, I've caught 200 of them, what should that probability be? I won't be able to give an exact answer, but I wonder if I could come up with a way, like a mental math method, to go like, if I do this and this with the numbers, I come up with a good estimate for how good his chances are. So to me, that's a problem that honestly for the past like year, I've been, for as long as we've been in like in not in lockdown, but under stay at home, and we've been trying to shelter in place, I have wanted to solve that problem. And I know it wouldn't be hard for me. I'm a math teacher, I love doing this stuff, but I've never taken the time to do it. This class, I hope, is going to be a class where we can try and engage with some questions like these, and I can walk you through the process of how to try and answer that question in writing and communicate it to other people. So I hope that we're going to do that in these next 15 days of lesson that we have. That's my vision, that's my goal. So my hope is that you've taken notes as you've gone through this thing, and that you'll, what I'm going to be doing is asking you to sort of like submit these notes online. You'll take a photo of them, you'll submit them on the Google Classroom, and I'll look at them. I'm going to read these things and try and give you at least a little bit of feedback on these things, because I really feel like the only way we get better at communicating math is by communicating math. So I hope that all of that made sense. If you have questions or if you have concerns, I really hope that you'll write those on the notes and that you'll submit them, or that you'll send me an email. Like I really, really want this to be a class about communication, math communication, and just in general communication. So I've had fun making this video, and I hope that you've learned a lot through it, and that it's been a positive experience for you. And I look forward to sort of chatting with you in class about this, or seeing you in the next video. So thanks a bunch. I'm excited for this journey.